see in the field. Shawn Smith is online. He's going to introduce the group and kind of where we are right now. You probably heard from our session earlier that this is currently on hold. And that is because it's been hard to get people to participate consistently. So when it's just 3 of us in a room, kind of looking at each other, it gets a little awkward. So this was one of the best practices that was really highly sought after. People wanted advice on their flow through systems. So we're hoping to revive this. And we're hoping that these conversations, these meetings can help us gin up some participation. And with some of the recent discussions during this meeting about 1, just having a common place to host this documentation, and then 2, actually having people support to do something like this, is a huge win. And so I'm hoping that we can start to build these groups out again and get these going. So with that, I am going to actually turn it over to Shawn to kind of introduce the first slide, and then you're stuck with me for the rest of the time.
All righty. Yeah. So thank you, Katie. If you can just jump to the next slide, and I will give a quick overview. So yeah, so this group was formed, oh man, it's been a couple of years ago that we started working on the general flow through best practices document. And as I've mentioned in the past, for those of you that have been on the group, you know, I'm kind of the cat herder for this. I'm a marine meteorologist by training, so I don't have much knowledge about flow through systems other than what I've learned from you all. So in terms of the details, you know, really need your input to be able to make this work. So again, the primary scope of this group is basically flow through systems from the intake into the vessel till the water gets to the sensors, you know, on the water wall. And with this idea, you know, basically we aren't really planning on talking much about the sensors themselves in this document. It's really about how to maintain, you know, the pumps, the tubing, the strainers, the, you know, flow meters, all those parts that are needed in the flow through system. So we started off, we do have a draft document that we've been working on, which I actually realized I don't think we put a link to this, but it's basically sitting on a Google Drive and we have to figure out what to do with it. So I think there's been some discussion of moving that someplace to a wiki under the RV Tech umbrella or the UNOLS umbrella, which would be great. We need to get this information out where you all can see it because there's a lot of good information in there. But where the draft is right now, we've really done a pretty good job of getting started on what are the components of a flow through system. We got a lot of information in there about different types of pumps, different types of, you know, meters and stuff. Basically, a lot of the pieces and parts of the flow through system, and a little bit in there about how to, you know, basically design and organize your flow through system in terms of the parts of the system. So there's a lot of work still to be done. We haven't gotten into any information about, you know, cleaning and maintenance, and there's all these different aspects. So right now I'm kind of thinking that the way forward is for us to, like, let's try to get one part done. You know, let's really focus on one section of the bigger document and move forward. So at this point, I'm just gonna you know, pass this on to Katie. She's got a lot of good information. We're gonna pass along almost everything that's in her PowerPoint is something we just need to suck into this document. But a lot of this comes from the What Went Wrong Wednesday session we did. I think that was in 2023 on flow through systems. So Katie, it's all yours.
All right. Thank you, Shawn. I'm going to minimize you. There we go. Okay. All right. Okay, so I'm hoping this is a really interactive discussion. So I have some polls that we're gonna do. It's gonna be great fun. I'm hoping to get some good responses and some stuff that we can then use to feed into our document. But I always want to start out with why do we care? Why is this important? So I'll start there. We'll do some polls. We'll do a crash course on the science seawater system, water well design, maintenance and cal-val practices, and then we'll close it out with another poll. Again, this is meant to be a discussion. I don't want to be up here talking the whole time. So feel free to raise your hand anytime you got a question, comment, whatever it may be. All right, so in terms of, and like I said, I always do this, I always put this up there. It's important what we do. We got to think about the whole data life cycle, and a lot of what we do starts at, data acquisition. That one point in time and space we're never going to get back. So you guys are the boots on the steel. You're the ones out there doing the hard work. It's really important that our primary data stewards have some guidance on how to collect the best quality data possible, because all of that follows the data through the entire data life cycle, right? So especially with the flow-through systems, I think one of the things that Shawn would certainly agree as well is that the more metadata we have about how your flow-through system is set up, the better, because it can be done in a lot of different ways. Ships are very unique when they come to their science seawater system design. So having that metadata on record, understanding how your particular ship is set up is really important. And it's really important for you to understand the nuances as well. So we're going to talk a little bit about pipes and pumps and all kinds of good stuff regarding that. So anytime you can capture some of that information, it's great because it's tied to that metadata record. Again, that who, what, when, where, why, how of the data. And we want our end users to understand that as well when they get a hold of the data. All right, so I break this up in two ways. Why do we care about this data in the short term? Why do we care about this data in the long term? And on here, I don't expect you to be able to really read these, but you can see, maybe, oh, now I did it. Stephanie, how? Not sure I know how to do this. Did I like hang up on everybody? No, okay.
No,
right,
no,
well-
we're still here.
Okay, good. I'm a disaster. Okay,
Do you want to go to the slides?
yes, please. Okay, I'm not gonna even touch that pointer, but what I want to show you here is basically on the short scale. We're talking daily measurements. We're talking, if we're measuring once per second, whatever it may be in our underway system, what we're able to see here are actually daily cycles within the phytoplankton. So you can, I'm gonna step away from the mic and kind of show you, but you can see, where it's going up and where it's going down. That's within a daily cycle. So you can see over here, right? These are between days. Over here as well, you can see some diel patterns. So scientists were actually able to utilize this data to look at diel cycles of different plankton and different organisms within the environment. For these examples, we're particularly using a sea star transmissometer and oxygen sensor. So there's a lot of value in having these measurements and just understanding, one, your biogeochemical cycles within the surface seawater. And imagine the power if we actually had this as continuous sampling platforms and we're able to derive this type of data over longer periods of time. We can really start to understand carbon flux and other really important dynamics within the surface water. All right, in terms of long-term timescales, I mean, we've been doing this for a long time, right? We've had a temperature, we've had a TSG in our flow, everybody pretty much has had a TSG in their flow-through system for decades. It is this data that makes it possible for us to understand long-term changes to our environment. When we talk about temperature trends, when we talk about climate change, that comes from the data that you collect and have collected for decades. So there's so much value in this historical data. And again, this is that part where it's understand the value of the data. We're not just days at sea. we've created these maps. This is just showing 11 years of temperature records and how those temperature records have changed over time. They have this data because these are actually all from shipboard measurements. So any data I've used here has been from shipboard measurements. And then on the right-hand side, this one's a sad one, but it's looking at whale entanglements and seeing that there's been a 400% increase in whale entanglements, and a lot of that has been attributed to surface seawater changes. Their food source anchovies are going further away into the cooler waters, and those fish or those dynamics change, which has them going actually closer to shore to get different food sources, and then they get entangled into these different into the nets. So it's really important for us to understand what this data contributes to, and these are just 4 papers, right? I mean, there's a mass quantity of publications out there that utilize this data, so it's really important what we do. That's the main point of these slides. All right, so enough of me talking. I'm going to try this interactive poll situation here. So if you guys either scan that QR code or go to that address, I'm going to activate the first poll. Maybe. All right, so the first question is, what is your experience comfort level with flow-through systems? And I guess I wish I could have showed the results. I can do that. That's okay. You guys are going to have to trust me. All right. Ooh, I've already got some answers coming in. We've got not comfortable, no experience, or little experience, 26% of you. Comfortable, some experience, 56% of you. Very comfortable, very experienced, 19%. Okay, so it's a little bit across the board, but mostly kind of in the middle there, right? Y'all feel like you have a little bit of experience with these systems? Oh, I did? Oh my gosh, I bet my subscription's lame. I didn't test that. You know how they just cap you? They're like, yeah, we're cutting you off at 20. You want to answer though? Are you A, B, or C? You got a long time on. Okay. All right, that's good. Excellent. Well, you guys better be trigger ready because here comes the next question. Ouch, yeah. No, we did not test that utility at all. All right. Second question's activated. What is your biggest concern with flow-through systems? And this one you can actually enter something and then you can upvote or downvote. Cleaning, yes. Big time. Blowing up the pump. Who is blowing up the pump?
I'm afraid.
All right. Variance in flow rate. That's a big one as well. Biofouling, yes. Flooding the ship. What are you guys doing out there? Stable flow. Okay, so I see a lot of flow. Pumps being able to keep up. That's an interesting one, especially as we get into the pumps conversation. So a lot of this is biofouling, location on the ship, and residence time of water through the ship pipes is a big one. That's going to be highly variable, and it's important information to know. It's funny because you guys remember Toby? Toby was like, we have to timestamp right when the sensor takes the measurement, right? I'm like, I think the bigger problem with time is probably how long it takes the water to get from the hull to where it's actually being measured. Because those can be really long residence times, right? And then you think about the thermal contamination that can happen between where your water is coming in and where your actual measurements are being made. That can be huge. And there are some good things that you can do in your flow through system to kind of monitor that. Did I see a hand? Okay, I want to make sure I wasn't seeing things.
Making sure that the water is being diverted the right way.
Yes, flow path. Yeah. Yeah, we'll talk a little bit about that with regards to active and passive sensors. Temperature attenuation in the pipes. Yeah. Okay, so lots of cleaning. When you should clean. Very good question. Oh my gosh, we have so much to get to. Okay, we're gonna go to the next poll, or next question is activated. What issues have you experienced with flow through systems? I'm actually guessing this is gonna be very similar to the last question. But flow path, yeah. Unstable flow, water everywhere, pump issues, biofouling, bad data, destroying computers, that must go with flooding, unstable flow, leaks, bubbles, bubbles, bubbles. Oh my gosh, bubbles are, yeah, nemesis. Okay. Very good. All right, we're gonna go to the next question. Do you conduct any field verification and or field calibration on your flow through sensors? Does everybody know what that is? The answer is. All right. Give you a second more until we max out tries here. Unsure is 50%, and the other yes and no are 25. Okay, that's telling. I like it. All right, I appreciate the honesty. All right, we're gonna head to the next one here. What kind of science seawater pumps does your ship have? Oh, that's a good point. Yeah, I see you, Katie. You're rocking the diaphragm and the impeller, I imagine. Yeah. Yeah. All right, so it looks like about 40% of people are impeller, 24% diaphragm, no peri pumps, no progressive cavity, and I don't know is 36%. So this is great because this tells you like it's really important to understand what kind of pump you have. And Katie's going to go on a soapbox here in a moment, all about pumps and why it matters. Until then, stand by. All right, next question. Okay, oh, this is a good one too. What kind of science seawater piping does your ship have? Anybody who was on this RV tech thread, like, oh man, it was probably 8 or 10 years ago. And there was like 30 pages of responses about seawater piping. That's like my dream. But it was like, it was really good. It was really good, actually. More than one. I should have allowed for that, right? It's like everybody's got PVC somewhere. All right, PVC 55%, Teflon lined steel 15%, polypropylene none. Glass reinforced or fiberglass none, steel 4%, other 8%, 16%, I don't know. Okay, we'll talk a little bit about piping today too. Specifically, like mostly just with your scientific seawater system. So from the intake all the way up to where your sensors are. Okay, this will be a good one too. Does the ship regularly clean the scientific seawater system piping? Yeah, oh, look at all these yeses. Okay. We're evening out now. We're about 50-50. Okay, that's actually really good because I'd love to hear for the people that do clean their system, how they do it. We're gonna talk about that here in a moment. All right. Last question, just to raise a hands. How many people enjoyed the interactive poll? All right, yeah. I'll do better next time with my subscription. We'll just test it out. All right, so a little bit about a crash course on science seawater system design. Again, like I said, knowing your system is the first step to ensuring that you're getting quality data and that you're providing the right metadata information to the end users, really. This is a very, very generalized depiction of what a science seawater system might look like. And just some considerations in terms of if you ever have the great opportunity of designing a science seawater system, what you might want to take into consideration, what you might want to note, things that you might want to do. So intake depth or intake step, intake location, this is all good metadata capture, sea chest coating and or cleaning capabilities of your sea chest, intake temperature, what, where, how, piping and insulation, cleaning mechanisms, either within your scientific sea chest or within the piping itself, basket strainers along the way. How many people have how many people have basket strainers? How many people have duplex basket strainers? Okay, one. Yeah, but it's worth it. But it's worth it. Oh, man. These port engineers, we'll have to get on them. And then pumps, of course, there's been a large effort in the community in many ways to shift from impeller to something else. Again, we'll talk about that. And again, this is just showing, okay, you typically have a grate on your hull. It's, got a mesh size of a few millimeters, so you don't, suck up any logs or anything. It goes into a scientific seawater chest. You want to try to, with scientific seawater chests, it's pretty interesting in terms of design. Some of them are now being delivered with these ultrasonic probes for cleaning. And there's things you want to consider there. When are you running this ultrasonic probe? Do you know what an ultrasonic probe does? Puts out a high pulse noise that will burst the shit out of cells. So if you are measuring cells, if you are measuring phytoplankton as your primary measurement or as a measurement in your system, if you have a fluorometer, it means you're measuring, chlorophyll, phytoplankton, and you will be bursting those cells, right? So you want to think about, you want to understand when that cleaning is happening and be able to make sure that you're controlling when that cleaning is happening. So that's important as well. But I love the idea. It's great to be able to clean those systems. Excuse me. So being able to have an intake temperature as close as possible to where the actual intake is. This shows, having the option for a freshwater flush or being able to inject a cleaning agent as close to the intake as possible, and compressed air blow down as well. And here you have a duplex basket strainer. The one really nice thing about that is you can basically isolate one of the strainers. You can throw a bleach tab in, or you can put whatever you like to pickle your system with. And then you can easily switch it over and flush things through. And then pumps. I'll go on pumps in a minute. Okay, so here's my soapbox moment. Before I came to NOAA, before I was into ship design and shipbuilding, with the RCRVs, I was a biogeochemist. And so I would go out to sea, and I would take these beautiful photos of this phytoplankton. So that was a cruise, I think, out in Hawaii. And so this is a little bit about phytoplankton appreciation. I just want everybody to just take a deep breath really quick. Just breathe in, breathe out. Isn't that nice? We like oxygen. So phytoplankton are responsible for a lot of that oxygen that you were just breathing. So we should be really nice to them. We want to understand phytoplankton dynamics, right? So we need to think about them more so as particles. So when you have an impeller pump going, churning up the water, you are basically ripping those phytoplankton apart. Yeah, see, tears. And so it's really important to think about, pumps with that regard. How do you preserve phytoplanktons? How do you preserve cells in general? Because we're actually trying to, measure them. There was a great paper by Ivona Setnik and others on characterizing the phytoplankton soup. And there's a link to it here. And they basically looked at the effect on phytoplankton and other organisms based on pump type. And it showed that there was a massive reduction in terms of a lot of soft-celled organisms, for sure, like ciliates and other things that we might be interested in measuring, but phytoplankton as well. It really did affect them. So one of the between a impeller pump and a diaphragm pump is what they tested. Diaphragm pumps are a little bit tricky sometimes. We'll talk about that in a minute. And progressive cavity pumps are great, but they are very expensive. So those are just some, considerations to have, because a diaphragm pump you can get, $10,000 to $20,000. Progressive cavity pump, you're talking about $50K. So for one, so while progressive cavity pumps have their benefits, they both kind of have their pros and cons. Okay, I'm off my soapbox. Just remember the phytoplankton. So yeah, exactly. Oh, I guess I don't have my slide in here about pumps, but I guess I pretty much already chatted about it. We can talk. I think I have another one in here. If I don't, I'll come back to it. In terms of the uncontaminated science seawater system maintenance, one of the biggest questions that we got when we originally kind of polled people about what they wanted to see was, how often do I actually clean it? How often should I run a cleaning cycle? And our recommendation really is work with the engineers to flush the sea chests and science seawater pumps with bleach at regular intervals. So this is what this paper actually says. And this is a paper by Lori Jornet. She's fantastic, and others. And they basically measured O2 consumption in underway seawater lines. And they were able to see there was a lot of respiration occurring in those lines, meaning things were living in there. So they looked at a couple different ways to clean the system. And basically looked at bleach, and they primarily use bleach, and then looked at the cycles, like how often should they actually do it. So of course, when they say regular intervals, it's going to be highly dependent on where you're actually operating, right? Are you in Hawaiian waters? Did you just go through a crocosphere bloom? Like, are you in coastal zone? How often are your pipes or are your sensors getting biofouled, right? So they say, depending on where you are, bleach cleaning can be effective for up to 45 days following the treatment. And one of the big questions, and this is still something that's kind of a big topic within the community, is bleach the right thing to use? Some people say no, right? And it totally depends on the chemist and possibly the day you talk to the chemist, right? So it's something I think we need to keep tabs on and better understand, but I think bleach is kind of a good place to start, just with getting your systems flushed and clean. But again, making sure that you note when that happens, that you have that as part of your record as well. Freshwater flush after every cruise. And it's another interesting part of the discussion, and freshwater flushing through the piping system. Just make sure you're freshwater flushing everything. Oh, the other thing I should say about the bleach treatment is make sure your sensors are isolated and they're not exposed to bleach. That's not a good idea. They don't like that. Many of them don't like that, especially, yeah, just make sure they're isolated. So you just want that to be running through the piping of the ship. The other question is, I've heard some people say, well, we leave fresh water sitting in our pipes. Others don't. I think the jury is still a little bit out on that one as to whether or not that's a great idea. Others just drain them and leave them dry. Any comments, any questions? I don't need to talk. I mean, anybody got any questions about that in particular? Yeah, Jackie. I will come and get them. I will go after them, don't worry. No, I know. And actually I've already come across this with the ETs, because we kind of went through, we have ETs and we have engineers in our fleet that would do a lot of this work. So we've been having kind of talks about what's the right practice, how do we do it? And they're coming around. I'm wearing on them. Yeah.
From personal experience, letting bleach sit on your pipes and your O-rings and your PVC for days on end is very bad.
Yeah.
I see very high failure rates from that, but if it's just a flush for some amount of time and then flushed with non-bleach water afterwards, you're gonna get much better results. But no, it's generally not good to let it sit for days on end on components.
Yes, thank you. I should put that clarification in here. By bleach flush, I mean, you flush it with the bleach tab and then you flush it very well with fresh water after that. You don't want bleach sitting in your pipes.
Has anyone looked at what the effects might be of the standard levels of either chlorine, bleach, or bromine that's in the shipboard water, which is what we flush it with afterwards? And I'm hoping the answer is it doesn't do anything, but
I would say the answer is, I don't know. Yeah, I'm not sure. That's a good question though. Yeah.
Just on the point of bleach flushing, what we do, we connect the heating pump to the system and we actually circulate it for the time period. So it's not standing with bleach in the system, it's actually moved around in the system, which then reduces the time that we actually need in order to get it kind of clean.
All right. Yeah.
So our operating area is for the most part the Gulf of Maine and has not changed kind of ever. And I feel like we've picked up more stuff than ever this year. All sorts of different algae are getting in and flowing into the PCO2. And so I definitely, I do it myself. I don't even bother with the chief engineer. I just go down there and just open it up, bleach it. And we've been swapping strainers too. But I also kind of have an opinion on diaphragm pumps. We have seen kind of nothing but problems since they have been installed. Flow issues, flow rate issues, the pulsating effect they have, shredding apart the diaphragm to try to stop the pulsating, them being so loud that people can't sleep, even though they're in the bow thruster space. But I mean, impeller was also bad. My predecessor probably burnt out 2 or 3 of those, and they were also expensive.
Yeah, so pulsating is a known issue at these pumps. And one thing I think that does help is adding a variable frequency drive, and I don't know that you've had that. Looks like we have someone very excited to talk about this over here, so.
Okay, I don't know if we're all talking about the same pump, but what is Katie, what's the name of the ones we've got?
Graco,
The
Husky.
Okay, and so
And
I don't think
Flippy.
you could run those without the VFD. I
Yeah.
can't imagine it. They are very tricky to set up. I've spent a long time looking at various YouTube videos trying to understand how these crazy things work. It is possible to get it set to not pulsate. I don't know if you can make it super quiet. Those valves seem to click no matter what, but it is definitely possible to get it to run pretty well. I don't know how long they'll last before they do seem to, I think, heat check valves at times. But there is hope for them, I think.
Yeah, and I think if you are able to plumb the system so you can run them at an optimal speed, they're supposed to be low pulsation at that optimal speed. Now you have to be able to get there. So really thinking about when you do add a pump, thinking about the design, the variable frequency drive operating at the, the optimum rate, which is pretty high, I believe, and then diverting excess overboard, right?
I think your speed is going to be dependent on how much flow you want and or your pressure. Your air pressure is critical and is related to the pressure you want the system to run at. These things all have to be matched. If they're not matched properly, it will not work right. And I can't give you the cookbook right here, but it's definitely has to be set up right or it won't work.
Yeah. And those ones, you're talking about the electrically actuated ones, not the air operated.
I'm talking, yeah, the electric ones, although the air would probably have similar issues.
Yeah. Any other comments?
On the Shimada, when I was there, he left the fresh water in the pipes, bunch of hydrogen sulfide would build up. I did not see that on the Dyson. Maybe it's temperature is different. And the other comment I have, yeah, we had some accidents with the impeller pump, so they burnt out, and it's usually the plastic part, and you can just buy the volutes and replace it, and it's much cheaper.
Yeah. Has anybody actually tried the progressive cavity pumps? Nobody's got enough money. Nobody's won the lottery.
Is that the same as a screw pump? Or is that different?
It's different. It's slightly different. I think people tend to, they have a similar way of operating, but I think sometimes people call them screw pumps, but they're actually cavity or progressive cavity. Same kind of mechanism though. All right. So crash course on water wall design. So we're going to talk about, know what your sensors and your systems are, right? That you have in line. We're going to talk about 2D bubble or not 2D bubble, order of operation, sensor orientation, flow rate, tubing and fittings, other tips and tricks. We don't have much time either, so. Oh, we got 25 minutes. I'm not keeping you here past 4:30 though. All right, so in terms of what we're going to discuss today, debubbler, flow meter, like Shawn said, we don't focus specifically on sensors within this document, but more so on how do you define that sensor in terms of your flow through system, and that may be orientation, that may be flow path, That may be, do they get debubbled or do they not? Are they active or passive sensors? We'll talk about that just with these specific sensors. And we do have a table that we have to provide that kind of summarizes the different flow rates for everyone. In terms of a debubbler, I think everybody and their brother has seen this before. It's been around for a long time. There's not really many other options out there. This is called a vortex debubbler. Basically, it removes bubbles from the sensor stream, right? You can get in a couple different sizes, 2-inch, 3-inch, depending on what you want. In terms of flow rate, always consider that about 25% of it should go out through your exhaust. In terms of maintenance, these do unscrew. Some people don't know this. You can clean these. Please clean these. They get really gnarly. I got a picture the other day and it was like, I'm not sure this has ever been cleaned. And then you look in it and you're like, oh my God, this is like one of those 1900s houses where they change the plumbing and you can only see like through it a little bit. And this is like a 3-inch debubbler. You're like, this is bad. So clean it. They do unscrew. Yeah, Gretchen.
A fun idea to clean these is to buy a new toilet brush and to swirl it around in there.
Okay, nice.
Use a bucket though when you open it.
Yeah, that's a good idea. Another thing that you can do to help reduce biofouling and get out your crafty side is add a little neoprene, sew a little neoprene cover for it. Some, or black fabric, something, or spice it up if you want. But just make sure you can't see through it. That makes sure the light can't get into that, tube there and reduces the biofouling. And then have it on Velcro so you can peek inside and see if it's fouled or not. Aluminum foil. All right. See? Well, you want to be able to see it. So see when it's fouled. Yeah. So the Velcro is nice. Yeah. And you can add little designs to it. You can add patches. I mean, you can get creative. That locking ring at the bottom is pretty easy to remove. Back in the day, they used to not be. So now they are. Just a little pro tip there. You can unscrew that. Cleaning frequency, again, depends on your operating environment, right? So, keep an eye on it. That's the nice thing about these systems is you can actually like peek in on, see what's going on in there. If you start to see green or it's a little hazy, give it a little clean. So how does this work? Well, water goes in the top there. You have an exhaust in the side top there. You have an exhaust out and the debubbled water. You have all this little vortex that gets created in that funnel there or in that tube there. And the debubbled water goes to the sensors, right? So out the bottom there. This is always a big topic of discussion. I'm curious to hear who has what kind of flow meters and what they like and what they don't like. Because there seems to be a lot of opinions in this community about flow meters, which I love it. So what do flow meters do? They just basically measure the flow rate within your seawater system. It's critical to being able to make sure that you have proper flow going through, but also you can utilize them to measure residence times within the system as well. So there's some common types available. The paddle wheel seemed to be very popular for a while. And that one in particular, I haven't had too many issues with other than once I lost I had to remagnetize it, which was interesting. But that seems to be one that I see really often throughout flow-through systems and then electromagnetic as well. Yeah, yes, something you want to say that?
Well, I despise the paddle wheels itself, but maybe it depends on how much like eelgrass there is where you live. But I think they're around originally because they were a lot cheaper, actually. I think we've seen setups that are probably a lot less than that. I think the electromagnetic stuff and other variations on that are coming down a lot in price. I keep looking at it and I think we may be at the point where we could just switch to nice things that didn't have anything in the flow stream, but I don't have a recommendation.
Yeah, I actually should have put a couple that we recently bought some and tested some out and they're also made by Omega. And so far they've been good. I also recently gave some to the Brown to test out like in real life. So I'll see what they have to say and we can put up those recommendations. I bought 3 different ones to try because we wanted to move away from paddle wheel as well. There's just too many points of failure. They're hard to keep clean, they demagnetize. You're like, what? And then in terms of general flow through system, flow recommendations, it's pretty broad, 2 to 10 liters per minute. Just kind of depends on the sensor, so good luck with that. I'm just kidding. There is a really great reference, and there are ways that you can design your flow through system to really optimize flow rate paths. You can diverge and do a few things to make sure that you're getting the right flow from the sensors you have in line. But this is a really good best practice document. If you guys are ever interested, it talks a lot about pumps and piping from science from NASA PACE mission. This is, I don't expect you to read this, but this is just for you for reference. These are the different sensors you might find in a flow through system, the different models you might find. We've got some new pH sensors to add to that list that we're trying out right now. What is the recommended factory calibration? Do you debubble or do you not debubble? We'll talk about that in a moment. Ideal flow rates, and this is the manufacturer's ideal flow rates. Supporting measurements. Are there any measurements that you can take that maybe, you know, if you take a specific measurement like pH, then you need to be able to have temperature and salinity to be able to do some corrections. So the other piece to it is field verification and or calibration procedures. I think I heard quite a few of you say, I don't know. I don't know if we do those things. So this is really, these are some options to consider for checking in the quality of your data. A good example is that transmissometer. If you were in the best practices session plenary this morning, we talked about publishing a transmissometer document that has recommendations for dart counts, you know, being able to just monitor dart counts over time, doing error and reference counts, doing comparisons as well. So just some recommendations for what you can do when you're out in the field to debubble or not to debubble. So the rule of thumb, at least, you know, and this is pretty generalized, but if it uses light, it's right to debubble. So all optical for the most part, right? So if you think about anything that's using light scatters off bubbles. So it is, bubbles are the arch nemesis of a biogeochemist who uses optics to measure phytoplankton dynamics. Trust me. So you want to make sure that you're supplying debubbled water to a lot of those sensors that may use light to measure particles. So your fluorometer, your transmissometer, and I say if it measures gas, then pass, because it's measuring gas. And if you are debubbling the water, you're removing gas from that water, right? So we don't want to do that. Anytime, excuse me, anytime, you know, bubbles do get introduced in the system, we work in rough seas, we have bubbles coming in. Sometimes we can't always control that. Even with these debubbler systems, we have micro bubbles that can come in and just cause a lot of health. Sometimes even after the debubbling, we screw one of those hose clamps on a little too tight, and that actually introduces air. So anytime you're thinking about bubbles and how you can reduce bubbles in your system, it's good to think about always having them push bubbles up and out, right? So when you're thinking about putting a sensor in line, think about that orientation. You want it to go in the bottom, out the top. You want to push everything out, right? You don't want to create a space where bubbles can just sit. Create the path of least resistance, right? So other trouble with the bubble techniques, you can add a little bit of back pressure downstream. That can sometimes help. Have slightly higher flow rates. You know, if you do start to see weirdness in your data, I'll show some examples of bubbles in a minute. Then always check your flow first, because a lot of the times it's a flow rate issue. Don't over tighten. Like I was just saying, if you over tighten, you can really easily introduce air into the stream. You can also, work on designing something so you can degas. You can have a degassing Y at a high point with a valve that can help release air. So having an air bleed. And this is kind of what noisy data looks like. So I put two examples on here. One is a sea star, and this is a pretty typical bubble response for a lot of optical sensors, right? It's just chaos. You have in the blue is where you have bubbles, and the red is where you do not have bubbles. So that's basically what it looks like. On the right-hand side, it's a pink shows when bubbles are present. So, and this is with a conductivity sensor. This came directly from a Seabird Tech manual or something I found. But the spikes typically display lower values if you have bubbles in the system, and then you can see at the bottom or at the side here where bubbles were actually purged and what that signal should look like. So noisy data, you start to see bubbles, it's usually an indicator of bubbles when you see spikes like this, and always check your flow rate first. Okay, tubing and fitting. Anybody got questions? I'm just up here talking. Questions, comments? Love it, hate it, useful. Okay, I see a thumbs up, I'll take it. Always maintain a spare set of tubing on board, right? You want to be able to easily swap tubing in and out. I think that's one thing. Whenever I go on a ship, I do a pinky inspection. Anybody do pinky inspections? You take a tube off, just rub your pinky in there and see what comes out. No, that's just me. Yeah, it's usually pretty gross. Okay, you can do a Kim wipe too. But that's an easy way of doing it, right? Grab a Kim wipe, use your pinky, whatever you got. Wipe the inside of the tube. If you see funk, replace it. And then it's always nice just to have a full set of spare tubing on board. You can replace it really quick and then you can clean that tubing out. Minimize tubing lengths as much as possible, right? You don't want to create any vertical, loops. You don't want tight bends, keep it simple. Go dark and opaque when you can. It'll help reduce biofouling. I see a lot of clear tubing on systems, and it's good because you can see when biofouling happens, but it's bad because it helps promote biofouling. So do the pinky test instead. Use quick connect fittings. Oh my God, I love quick connect fittings, unions, whatever that it makes it easy for you to take that off, check it out and put it back on. And also getting away from the hose clamps that we just tend to tighten down and then add air into the system. 12 minutes, okay. Tubing type, there's a lot of information here on tubing type as well. These are just a couple recommendations for types of tube and how do you clean it? This is just like science seawater piping, right? There's a lot of ways that people do this. Bleach, RBS, church tall, those are all good options. And again, like I said earlier, cleaning should not happen when sensors are in line, right? Never expose your sensors to chemicals. Yeah. Questions? Love
What
it.
are your thoughts on cleaning with giant, like the brush, toothbrushes? Like where
Toothbrushes.
you clean with your straws and stuff,
Yeah.
pipe cleaners.
I don't really have any thought. I mean, that's great. Like if they're really dirty, scrub them. Yeah.
Okay.
The only thing I could think of is if you were using semi-rigid tubing and that scratched it, you could create areas either for more tubing to stay or bubbles, but nice soft microfiber. I don't know. Yeah.
I don't know how many other ships have it right now. I believe they're planning to have it roll out on more ships. But Chris Melrose of UNH brings out a TA sensor for us and has specifically requested no bleach runs through those lines.
Yeah, like I said, the chemist and the day you talk to the chemist. Yeah, it totally depends, right? Because it does affect their measurements. So it is always good to check with science. Okay, in terms of order of operations and sensor orientation, I'm gonna pick up the speed so we can like talk a little bit before this ends. We define active sensors as sensors that may alter the stream and affect measurements downstream. So really think about what you have in and what you might be affecting early on. If you have reagents, you have an alkalinity sensor in line, you have a pH sensor that utilizes reagents, you don't want to send that outflow to another sensor, right? You want it to be on its own path. Passive sensors don't affect, measurements downstream. This is going to be like your thermometer. Sensor orientation, sometimes it matters. So really as much as you can, have the water flowing through the bottom and out the top. Again, path of least resistance. Think about water flow. And pay attention to that flow path. Other tips and tricks like contamination. Any contamination could affect both your measurement and cause biofouling. Filtered signals for measurements of particles. I'll talk to anyone who wants to talk to me about this for hours over dinner. If you're interested in filter signals and having an automated filtration system that allows you to look at biofouling over time. It's pretty awesome. Flow through wall design. So, you know, we talked about having this 3D printing repository for sensor mounts, and I think Kate Kuba started this, and it would be a great resource for the wiki. So stay tuned. We might have be able to provide some 3D printing for sensor mounts. Are they? Yeah, if you guys don't know about it, there's some really great designs in there. And then just thinking about materials, like, you know, starboard's heavy, but it's nice, it lasts. If you can do threaded inserts, that's really nice for when people come and plug and play their sensors onto your ship, to be able to get them on board and mount them up and off the bench if necessary. And flexibility and manifold design, you know, again, union fittings are really great. It's easy to take them apart, clean them. Really thinking about having multiple different streams people can plug and play into. Okay, last poll. We have 8 minutes, so we're gonna do this. Okay, what would you like to see included in the general flow through best practice document? Stand by, my computer went dead. And you guys can just start shouting too if you're interested. Pictures. Okay. Yeah, we did have one in that early, and there is one in the document that kind of shows a general, okay, it's live, a general flow path for different sensors. Okay, pictures, good. So many upvotes for pictures. That's all you guys want. Pictures and more pictures. That's all I've got. A downvote for, no, that wasn't it. I think somebody messed up. Visuals, diagrams, cleaning frequency and processes, McMaster part number list. Who put that? Because I've got it for you. I have it, like everything. Yeah, it's fantastic. Tips and tricks for cleaning. Yeah, those are all really good. Really good information. All right. How would you like to see these documents get shared in the community? I think we actually answered this today, and that we're going to attempt to get a wiki, which was a huge step. So what is, this is just, what is your affiliation and position? I think everybody here is Academic Fleet, NOAA, for the most part. Am I missing anything? We got a few vendors here, who I guess are both. All right. And are you, this is the most important question. Are you interested in participating in this email group? If you are, go in, put your email. If it doesn't allow you to, because we put too many people. Oh, I gotta activate it, don't I? Yeah, I didn't activate any of the other ones. Sorry, guys. All right.
Just so you know, Katie,
Yeah,
there are currently 30 people on the active mailing list for this working group. So
30. We have right now, we have about 3 show up usually.
yeah, usually. So
Yeah, so if you're interested in joining, like, one of the things, and even if you're not interested in joining, even if you're like, I want to know, I want this to be in the document, I want more information about this, email it to us so we know and we can add that. And hopefully once we get participation up again, then we can get back on again and work on a document. Shawn, you got anything to add?
yeah, actually I have a question that I just thought of that's related to this, which is, you know, what would help you help us in the working group? So we talked it came up a little bit about the idea of some actual support for, you know, shoreside support for technicians to actually have time paid to work on this. But is there anything else you can think of? What would it help? What would help you help us, basically?
Anybody?
Lock them in the room and don't let them leave till we have a document.
Yeah.
There we go.
Yeah.
You can talk about that.
I have an add-on for the diaphragm pumps that I was thinking about it more. Those pumps absolutely have to have back pressure on them. They will not function without back pressure in the system. And you really need a gauge at your discharge, and you need to correct for the difference between the height where the pump is and the losses in the pipe and what the pressure is at the other end. And there's more to it, but that's, you gotta start there, you won't get anywhere.
Thank you. Anybody else? Yeah, Gretchen.
So while we're waiting for the Wicca page the Wiki page to be developed, is there a way we can access the documents such as the McMaster parts list and all the other goodies?
For NOAA people, Linkapalooza.
Linkapalooza.
Yeah. Yeah, we have an internal thing called Linkapalooza that has links to everything. It's not the best way to manage documents, but for other people, we'll get the wiki going. But yeah, I have the McMaster parts. I have a recommended document for how to build a manifold, and it has all of it in there. Yeah, I'm a dork. I love this stuff. Yeah. All right, anybody else? Because we've got 3 minutes and then we're done. Anything?
So, just FYI, I just threw the link to the Google Doc, not the NOAA thing, the Google Doc for this working group in the chat. So I don't know if you can show that or not, or share it in any way, shape, or form. But yeah, all you have to do is ask for, an invitation, to that, and we can share that. That's where we have all our documents, the working draft, everything's in there. At some point, we'll figure out how to move all that over to something like the wiki. But if you're interested in looking at it now, it's there.
Thank you, Shawn.
So that being said, if you really like Wiki and you want to help start it, like start putting some information in, let us know. We can work with you.
All right, last question, then I'll release you all. Was this useful to everybody? Hopefully, raise your hands. I see a lot of nods. Okay, good. All right. Well, thank you all for your time. If you have any questions and want to talk about this over red wine, I'm here for it all night. Yeah. Thank you so much.
Thanks all.